Good morning everyone, this is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering, Coimbatore. So in the last video, we discussed about transform coding. Let us see the recap of transform coding. So transform coding is a widely used method in image and video compression. So the main idea of transform coding is to convert spatial data, that is pixel values, into frequency domain data, where most of the useful information is concentrated in a few coefficients which can be compressed efficiently. And we saw the advantages of using transform coding, that is the main advantages are energy compaction, compression efficiency, reduction redundancy, flexible compression control, smooth image reconstruction, and it can handle various image types. So in this video we are going to see about wavelet coding. First we will discuss the basics of wavelet transform. So the wavelet transform decomposes the image into different frequency subbands, that separating the image into low frequency and high frequency components. Low frequency components, that is low frequency subbands, it represents the general shape and structure of the image, and the high frequency subbands represents the fine details like edges and textures. So it applies a series of scaling and wavelet functions to the image to represent different frequency components at different scales. So the image is broken down into multiple levels of frequency subbands. So this is the block diagram of wavelet coding system. So in this, the input image is given to the wavelet transform. So and then the output, that is the broken image, is given to the quantizer. In quantizer, it reduces the precision of wavelet coefficients to compress the data. Also, it eliminates less significant information, focusing on preserving essential features. So that a quantizer may introduce some loss in data. That is, it is because it is mainly used in lossy compression. So particularly in the high frequency subbands that present fine details. So there are two types of quantization. Scalar quantization, it uniformly reduces the precision across all coefficients. Vector quantization, it compresses the groups of coefficients for most efficient compression. So the output of the quantizer, that is the quantized coefficients, are given to the symbol encoder. So the encoder encodes the quantized wavelet coefficients into compressed bit stream using entropy coding techniques. So there are some coding techniques used for encoding, that is run length coding, Huffman coding, and arithmetic coding. So run length coding mainly used to compress sequences of zeros efficiently, and the Huffman coding mainly used to assign variable length codes to symbol based on their frequency. And the last one is arithmetic coding. It compresses the data into single fraction, offering better efficiency than Huffman. So the output of the symbol encoder is a compact compressed bit stream representing the image data in an efficient manner. So the output of the compressed data is given to the symbol decoder. So the main function of symbol decoder is to reverse the process performed by the symbol encoder. It decodes the compressed bit stream into quantized wavelet coefficients. So the decoded quantized coefficients representing the decomposed image, and the output of the decoder is given to the inverse wavelet transform. Here it attempts to restore the precision of the wavelet coefficients. However, in lossy compression, some information is lost permanently. So this step can only approximate the original values. So the dequantized wavelet coefficients, which approximate the original transform coefficient before the quantization. And the final output of the wavelet coding process is, if the process, that is the decompressed image, is the final wavelet process. So if the process involved lossless compression, the reconstructed image will be identical to the original. In lossy compression, the reconstructed image will be approximate the original with some loss in detail or quality depending on the compression. Next we will see the advantages and applications of wavelet So the main advantages of wavelet coding are multi-resolution representation. That is, wavelet transforms analyzed data at multiple resolutions, capturing both fine and coarse details. This makes it ideal for compressing images and videos at the different quality levels. And the next advantage is no blocking artifacts. That is, unlike the DCT based methods, that is JPEG, wavelet coding does not use blocks, so it avoids block artifacts. And adaptability, it can handle the local features better. And scalable, that is, wavelet coding can efficiently represent both low and high quality images from the same compressed bit stream. And it can be used for both the lossless and lossy compression. That is, it can be used for dual mode. So wavelet coding supports both lossless and lossy compression, allowing flexibility depending on the application. It is mainly used for medical imaging for lossless and image storage for lossy. And main applications of wavelet coding, that is JPEG 2000, medical imaging. So medical imaging uses a lossy compression. So the wavelet coding is used in medical applications where preserving the exact image detail is crucial, so that in CT scans and MRI images. So lossless wavelet coding ensures no information is lost during compression. And other applications are video compression, progressive image transformation, and fingerprint compression. So hope this video will help you to understand the basics of wavelet coding. Thank you.